Hello, I'm going to do a little demonstration today, fairly quickly, of how to conduct an independent samples t-test using Excel. The question we'll be answering is this: do statistics students who are randomly assigned to teach someone else a statistical technique score higher on an exam than those randomly assigned to study the technique alone? Use probability level 0.05. You can see the data here, make it too long and too complicated to do this problem by hand. So we're going to work through this using Excel. First, I'm going to scroll down and put the basic steps that we work with every time. Population 1 in this class is students who teach a statistics technique to somebody else. And population 2 that we're comparing it to is students who study the statistics technique alone. Our dependent variable is exam score. It says that we are looking to see whether the ones who teach the technique score higher, which makes it a one-tailed high test. And the hypotheses we're going to write in short form now. The research hypothesis, or H1, is that the mean exam scores for population 1, which we're going to write as mu1, will be higher. So we'll use the greater than sign than the mean exam scores for population 2. And the null hypothesis, H0, is that the mean exam scores for population 1 will be equal to the mean exam scores for population 2. You'll note that I'm not making these in subtext. It's a little tedious to do that. It can be done in Excel, but for the most part, I'm leaving my numbers full size and you can do the same. Our next step is to identify the comparison distribution. We know that we're going to be comparing the difference between the mean scores for these two groups, and we're going to compare it with differences between means. So a hypothetical population in which two means were drawn out of the population, compared and put back in, and done repeatedly until we get the T distribution of differences between means. And the center of that distribution, when we compare all those differences, is mu equals 0. And the spread is represented by the standard deviation, the estimated standard deviation of differences between means, which I'm going to just label as S differences, and that we have to calculate. So let's go below now and begin that calculation process. You'll notice that I've organized my work so that it's easier to read. I will zoom out a little so you can see how I've done it. You can just see here that I added some delineations between the solution to my problem and the calculations. And I always appreciate if you do the same because it makes it easier for me to grade your work. I already filled in the N. We have 21 students in condition 1, and we have 19 students in condition 2. So those I've filled in, but the rest of this information remains to be completed. I'm going to draw this out here so that I can actually see the formulas that I've gone ahead and written in so that you can see exactly what we're doing. So first off, the formula I have to apply is n-1. I always begin my formulas with an equal sign. I will click in the cell corresponding with n and just put -1. I'm going to, and next I'm going to calculate the mean. I'm going to do this. We all have all done this in its raw form, but I'm actually just going to write equals to tell we're doing a formula. You can see it up here in the formula bar. I'll write average, and I'll put in parentheses what I want to average. So to do that, I have to leave my cursor up here in the cell and go back up to these values, these scores, And here we have the calculation for the average, and that equals 83. Next, I have to get the sum of squares, which I'll do by subtracting x minus m to create the deviations. I've already filled in the m up here is mean of 83. We can copy it and paste it all the way down. And the deviations, I can just type in the equal sign. You'll always see it up here in the formula bar. I type in the equal sign and I will write, what are we going to calculate? We're going to take x minus m. Put the end parenthesis, that's calculated. Now I'm going to go to save time and just go ahead and do the square it. So I'm going to go equals, and I'll just go deviation squared. We could do this all in one space. I still do it this way so that it's easier for students to see what's going on. So now I'm going to copy both of these by selecting both of them. I'm going to copy them using Control-C. This vibrating line means they're copied. And I'm going to paste these values all the way down to the end of the data set. I'll use Control-V. You can see now that it's calculated deviations and the deviations squared. And so let's go see what else we can do on this side before we continue. We can calculate the sum of squares, so we'll go ahead and do that. That is just the sum of all those squared deviations. So let's go equals sum and put a parenthesis so it knows what we're going to sum. We're going to sum all of these deviations, T7. Oh, I have to scroll down. I'll hit Shift before I put my cursor in that bottom cell. That will hold it in place. So here's my Shift key pressed, and there I'm going to click in that last cell. Now it grabbed it and enter. All right, so now we have the sum of squares, and we can do our last step. We can calculate the sum of squares divided by degrees of freedom to give us the variance. So equals, I'll type where the SS is, where sum of squares is, and I'll divide by degrees of freedom. I need to divide by degrees of freedom because we're estimating for a population with an unknown distribution. So here's our variance. So we're in good shape. Let's see what we can do to have the same things over there on the other side. We can do the degrees of freedom equals n minus 1, or you can just write it in, of course. I'll calculate the mean using that average as we did before, and I'll put the opening parenthesis. I'll go up and place my cursor in all these scores to select them. Now it's grabbed, as you can see, Y7 through Y25. That's correct. And there's our average. Next, I'm going to get the sum of squares, which means I have to calculate the deviations. As you can see, I've placed the mean into each cell. So now I can just do a simple calculation. Equals x minus m. I've done that for the first one. And now I just need to square it. Equals squared. And that looks correct. So I'll copy it, copy both cells this time, and I'll paste them down to the end of the data set using Control-V. And now we have all the deviations squared, which allows us to get the sum of squares. So equals the sum of squared deviations. There we go. 1838 is the sum of squared deviations, and I can also calculate the variance by taking the sum of squares and dividing by degrees of freedom. So we're in good shape now. We have two variances, and now, as you know, the complicated part, that's not really that complicated, is we have to average these out in order to get the degrees of freedom pooled. In order to get the variance pooled, we need to use the pooled variance because we're looking for a distribution that consists of differences between these means. So we're going to use both of these pieces of information, the variances for both samples, in order to calculate the variance that we'll use in all. And this is a little bit different formula, so we have to be proportional. We could just average them out, average out this variance with this variance, but our sample sizes aren't equal. And we can't give this one that only has 19 people or 18 degrees of freedom the same weight as this one that has 21 people or 20 degrees of freedom. So we have to weigh them proportionally. So let's figure out what the proportions are. I've used the abbreviation PCT to stand for percent. I want to know what percent of the degrees of freedom are for this group. And that's a very simple calculation. It's just the degrees of freedom for group 1 divided by the degrees of freedom, the degrees of freedom total. Aha, you say, but what are degrees of freedom total? We haven't calculated it. So let's place our cursor there and calculate it. You can see the formula that it's just degrees of freedom 1 plus degrees of freedom 2. So let's type that. Equals, here's df1 plus df2. Now we have that, and you can see that this calculation already took place. Let's make sure I didn't bungle anything. I'm clicking in the cell with this formula, and now I'm going to click up here in the formula bar. And when I do so, you'll see the cells light up blue corresponding with blue, that's the 20, divided by the 38, which is correct. So this 52, this is 52% or 53%, 0.526316. So 53% of the degrees of freedom belong to this variance. Let's do the same over here. Equals degrees of freedom 2 divided by degrees of freedom total. And we get about 47%, which should add up to 100. So it's all looking really good so far. So now we know the percent. Let's go ahead and figure out this pooled variance, because that's our next step. So what we're going to do is, as you can see in the formula, we're going to take the percent that we calculated for 1 times the variance for group 1 and add it to the percent for group 2 times the variance for group 2. So we can do that quite easily. Let's type equals and put our first calculation in. Equals, here's our parenthesis, and we'll get the percent 1 by clicking in it. I'll use the asterisk for times, and I'll click in the variance for 1 and put an ending parenthesis. So far, so good. Let's now put our plus sign and another parenthesis, and we'll take the percent for group 2 and multiply it times the variance for group 2, put our closing parenthesis. Our formula looks just great. You can see everything lit up. It's all perfect. Percent 2 times variant 2, percent 1 times variance 1, just what our formula says. Let's click enter, and now we have the pooled variance. I've left a space here in mine to remind me that now I need to go back over here. Now we have to figure out the variance for the distribution of means for group 1 and group 2. And this will go down here, variance for distribution of means for 2, variance distribution of means for 1. The formula, as you can see, is variance pooled divided by n for this group. So I'll type my equal sign. Here is the pooled variance, and I divide by n for group 1, same as we did before to get the distribution of means. We can do the same over here to get the distribution of means for group 2, so that we're comparing groups of 19, for example, with groups of 19. Equals variance pooled divided by n for group 2. And now we know the variance of distribution of means for each group. Now we're just about done. We just have to sum these variances to get the variance for the difference between rooms distribution. So we'll sum them, variance of mean 1, which is this, plus the variance for the distribution of means for group 2. We can see that we have this variance, and we need to work with actually the standard deviation. So we simply take the square root, abbreviated SQRT, of this variance. And now we have our what we're going to work with in our difference. So let's go ahead and fill that in. It is 3.213381. I think that I should copy that value maybe. Oh, I can't copy it actually. 3.213381. What I could do is copy it like this and then do a funny little paste, just pasting the value. I'll do that just to prevent me making a mistake. You can see up here that this is actually a much longer number than was shown. So I think I'm going to shorten it. Instead of writing all that out, I'm just going to write 3.21. However, if I'm going to calculate, I have to calculate with that whole number. So when I'm writing it as an answer like this, I can use 2 decimal places. But if I'm using it to calculate, every digit must be included. I'll take that out of there to avoid confusing us. Next, we do the cutoff. Our cutoff is going to be looked up in the critical value indicator. So it's going to be using a p-value of, let me see what I set up here again, of 0.05. So we're going to use the cutoff of 5%. We want to be more certain than 5%. Equals 0.05. And we're going to be using degrees of freedom total, DF total, and that equals 38. And when we use our critical value indicator to look that up, we find that we get, I'll just pull it over here. We have 38 degrees of freedom with 0.05. We'll calculate, and we find out that for our one-tailed test, 1.69 is the critical value that we're going to look into the tails for. So 1.69 is what we can put here for a cutoff, equals 1.69. And we were looking for, let me make sure, high, so that would be a positive 1.69. You can see that's a nice low value, and that's because we have such a big sample. Now we need our t-score for the sample. I have the formula for it written down here. So M1 minus M2 divided by the difference, standard deviation for the difference between means. So let's go ahead and do that formula. I'm going to type my equal sign, and I'm going to put an opening parenthesis so I can do the subtraction. I have to use that subtraction first because we want it to subtract before it divides. So here is the mean for group 1, 83, minus the mean for group 2, which is 75. I'll put my closing parenthesis. Now I simply need to divide by S difference, which is right here. And we'll hit enter. It looks good. It looks like the blue is split up there. That's correct. The red is there and the purple is here. This looks all like just what we should have. So there we enter it. We find that we have a t-score of 2.48959, which we will round to, we'll write t equals 2.49. But once again, this is just for writing it out. If we were actually going to calculate with it, we would use all the decimal places. So what's our decision? Our cutoff is 1.69. We have a t-score that's more extreme of that. I'm not going to draw this out this time because we can picture by now what this looks like. We can see our cutoff point at 1.69. We can picture ourselves shading that region beyond it, and we can see that our t-score is going to be in that shaded region to the extreme of our cutoff point. So our decision is to reject the null hypothesis. If we reject the null hypothesis, all we have left is the research hypothesis. mu1 is greater than mu2. So let's write up our conclusion. Our conclusion is, let's see, students who teach a statistics technique to somebody else. I might as well take this since it's filling it in for me. Now, right here, this is our population 1, and I'm going to write in the mean. And we do this when we do an independent samples t-test, just to make sure our audience can see what the mean was. And in this case, I'll just write mean equals 83. I'm going to actually put the decimal places in. That's just protocol. Earn higher. I'll even write the word significantly. That means that it's statistically significant. Higher exam scores than students who study the, I'm just going to go to the next line here. That's the way it has to be done in Excel. The statistics content alone. Now I'll write the mean score for that group in, and that group had a mean of 75. I'll put an end parenthesis and then an opening parenthesis so I can put the statistics, and we'll put T, then we'll put degrees of freedom total in here, 38 equals, let's go down and see that t-score, 2.49. And that is significant. So we'll write P less than 0.05. There's less than a 5% chance that this has come up just purely at random. And that is the end of our problem. I hope you found it helpful.